Okay, so in the last video, we were talking about our t distribution. Our formula is here. We're going to try plugging into that this time. And the standard error is the sample standard deviation divided by the square root of the sample size. So here, suppose we have a health club that claims that its members have a mean pulse rate of mu equals 60. So that's our population mean there. Now we know that 20 members, so 20 members, that's our N. N is 20. Are randomly selected and their pulses are recorded. Here's our data. We want the t-score for it, and we want to know whether that means unusual. So first of all, in order to get the t-score for this, let's look back at that previous, I'm going to need my sample mean and my sample standard deviation to plug into these two formulas. So I'm going to get that from this data by going to my calculator. In the calculator, I'm going to hit the stat key, and then I'm going to go to edit, and I'm going to put this data in list 1. Once I have the data in list 1, I'm going to go back to the home screen on the calculator and again hit the stat key and go to calc and go to the one variable statistics. And that will give me my mean y bar and my standard deviation s. So now if I do that from the calculator, I see the y bar is 74.35 and the s is 10.04. Okay, so looking back, we're plugging directly into this formula here, where we're substituting this as the denominator. So this is my y bar minus this is my mu over this is the s, and this is the square root of n. Okay, so we're just plugging directly in these values there. And if you do that calculation correctly, your calculator should tell you it's 6.392. Now, then I'm going to hit the calc key. I'm sorry, the second key and the variable key to go into the distribution menu. And we want to choose this TCDF. Notice that, remember for before we were using our Z, the normal one, Z, right? Now we're using a T, okay? This gives us that probability. So the probability, we're going to go TCDF, our left bound, which is our t value, because we want to know what we're calculating here, is our probability is that area from 6.392 to the right on our normal t curve, right, that's centered at 0. So I'm calculating that shaded area. So I'm going to go from 6.392 to infinity, right? Something really big, so infinity. And then the degrees of freedom, since my sample size is 20, my degrees of freedom is n minus 1, so that's 20 minus 1, or 19. So that's what I'm putting here. And if you do that, you're going to get a very, very small number. It's going to tell you like something 3.93 something e negative 6 or something like that. Remember, that means put 5 zeros and then the 393. So it's way less than 0.01. Now, I can decide unusual based here either on the t-score or on the p-value. This being less than our alpha, or this being larger than, remember for z's it's 1.96. So anything bigger than 2. Now, we have a little bit more leeway with the t-curve because for a small sample size, 2 may not be that unusual, but as the sample size gets bigger, and certainly for 20, all the way out at 6, that's a very unusual. But so that's why you look in conjunction with the p. Okay, you want to see how close, especially when you're close to that 2 value, look at the p and see, is it bigger than the alpha? And that will tell us whether it's unusual. So in this case, yes, this result is unusual, right? Because we got a very different value of t. All right, so we'll pick up there on the next video.